Hello and welcome to Algebra Chapter 1, Section 1. We defined algebra in class as the branch of math that uses letters. So let's talk about those letters. Their formal word or definition is a variable. A variable is a letter or symbol used to represent an unspecified or unknown number. So the number that we don't know, we're going to represent that with a letter called a variable. For example, X is the most popular variable. Sometimes you'll see S, and I would like for you to always put a little tail on your S so that we don't think it's a 5. T is a very popular variable. But sometimes in geometry they'll use a capital A for area or V for volume. So an algebraic expression is any expression that consists of numbers and variables. They may also include our arithmetic operations. That means they may include addition, subtraction, multiplication. I'm going to use the dot for multiplication, division. They could even use square roots. They could use exponents. So if I put a little squared up there, that's, in other words, something squared. That's our operations. We're going to talk more about the order of operation, which should be review. But to make it an algebraic expression, it has to have a combination of letters and numbers, like 5x plus 2. That would be an algebraic expression. Whereas just an arithmetic expression would be 5 plus 2. That would not be algebraic. So to be algebraic, there has to be a variable involved. Just plain old x is a algebraic expression. Okay, pi r squared is an algebraic expression. So the parts of an expression are called the terms. And the parts that have variables are called the variable terms. It's kind of obvious. And the parts that don't are our constants. In other words, x could change. In this problem, x could be a number of things like 5 or 7 or 10 or 1,000. But 2 is never going to change. It's going to be constant. So it's a constant term. So again, in 5x plus 2, this is your variable term, and this is your constant. The most common variable, I already said, is x. So we shouldn't use x to mean multiplication any longer. That's why I used the dot earlier. Parentheses is another great way of denoting multiplication. So if I just set 5 beside x, that's also understood to be multiplication. So you might say 5 times x or 5 times x using parentheses, or even 5 with just the x in the parentheses. So these are all ways of showing multiplication. Okay. The quantities being multiplied together are called factors. The result is called the product. The result of multiplication is the product. You should know that. An expression like x is called a power. By the way, this section is heavy on algebraic lingo, terms that we're going to need to know. So the word power can also refer to just the exponent, which is what we usually think of. The exponent indicates the number of times the base is used as a factor. In the example x to the n, the base is x and the exponent is n. We read this expression x to the nth power. When no exponent is shown, it's understood to be a 1. The power is understood to be 1. So a to the 1 is simply a. Okay, write a verbal expression for each algebraic expression. So take these algebraic expressions and put those into words. This is 8 times x to the second power and the fancy way of saying to the second power is, I'm going to let you fill in the blank. I'm going to check to see if you know the fancy way of saying the second power. Alright, this is y to the, let's first acknowledge that there is an operation going on here. Like we said, 8 times. Whenever there's subtraction, there's several ways we can say subtraction. The most obvious is the difference between, or the difference of, y to the 5th power and 16 times y. Now, I'd rather you not say y to the 5th power minus 16y, but if you say that, it's not incorrect. Okay, in example 2, write an algebraic expression for the verbal expression. So now they're going to give it to us in words, and we're supposed to write it out algebraically. The very first one that we come to is one that most students have a really hard time with. It's the words less than. Most everybody knows less than means subtract, but they want to get mixed up on less than. So I'm going to get my red pen and I want to write this very important thing. Whenever you hear the word than, whatever comes after than goes first. So whatever comes after than goes where? It goes first. So after than goes first. You need to remember that. So let me show you how this looks. 5 less than a number and c. Okay? 5, that doesn't make sense. 5 less than a number c. That's not supposed to be there. It's supposed to be 5 less than a number c. So which one came after the word than? C. So which one goes first? C. After the word than is a number c. Whatever comes after than goes first. So where does the 5 go? It's going to be less than. So it's 5 less than c. See how that works? It's very important on a less than problem that you put this in the correct order, or you may end up with a negative answer when it's not supposed to be negative. So 5 less than a number c. Anything after than goes first. So the c goes first. Remember that. We're going to work on that several times in class. Alright, 9 plus the product of 2 and d. So that's just straightforward. There's no word than. So we just say 9 plus product. Product means multiply, 2 and d. So I'm just going to write that 2d. This says 2/5 of a. I'm taking 2/5 of, means parentheses, a, or multiplication. 2/5 of a. You can also write that 2a over 5. Those are the same thing. They're equal to each other. Alright, Mrs. Pretty bought 2 adult tickets and 3 student tickets to the Adventure Science Center. Write an algebraic expression that would it's an expression, so we're not going to actually solve anything. We're just setting the problem up. An expression that would represent the cost of all the tickets. She bought 2 adult tickets. Okay, first we need to define our variables. A for adult tickets. We do not know what adult tickets cost. They didn't tell us. and student tickets. I'm going to use the S, and I put the little tail on my S so you don't think it's a 5 for student tickets. So this is adult tickets, student tickets. Sorry. Alright, so she bought 2 adult tickets and she bought 3 student tickets. And what if we knew the cost of the adult ticket and the cost of the student ticket, we could tell Mrs. Pretty how much money it's going to cost her. But since they're not telling us those costs, we're just going to set up the algebraic expression that would represent the cost. Okay? Alright, that concludes our first video. We will practice more of these type of problems in class. Thank you and have a great day.